Let's explore deeper into the polarizer's angles where the receiver gives low results. With the transmitter at position 3, the receiver is brought closer so the reading exceeds maximum scale. When the twin polarizers are at position 0, the reading drops to near 0, but slight displacement can increase it up to 20%. Position 0.5 gives the same result. At position 1 it can increase to 80%. But at position 1.5 and 2 it's near 0. At position 2.5 and 3 it's over the maximum scale. Let's turn the transmitter to position 2. The reading is down to 0. With the twin polarizers at position 0, the reading is still 0. At position 0.5 it's still nearly 0. At position 1 it goes up to over 80%. At position 1.5 it's over maximum scale. At position 2 it's just around 100%. At position 2.5 it's reduced to 5%. At position 3 it's just 0. Let's turn the transmitter to position 3. The reading is around 100%. With the twin polarizers at position 0, the reading becomes 0. At position 0.5 it's still nearly 0. At position 1 it goes up to over 40%. At position 1.5 it's around 100%. At position 2 it goes over maximum scale, so does at position 2.5. At position 3 it goes down to just over 40%. Let's turn the transmitter to position 0. The reading is above 100%. With the twin polarizers at position 0, the reading becomes 0. At position 0.5 and 1 it's still 0. At position 1.5 it goes up to over 20. While at position 2 it goes over maximum scale. So does at position 2.5 and 3. Let's review the results where it's nearly 0. When the polarizer is at position 0, the reading is 0, but if it's slightly moved around, we get some reading. At position 0.5 the polarizers block the microwave better. At position 1 we can see some reading again. These results show that electrical connection between those polarizers really made a difference in how they react to incoming microwaves. Next experiments will try to determine if the electrical connection between two polarizers has effect on the orientation of microwave coming out from them. The distance between transmitter and receiver has been adjusted to get 100% reading when they are both at 0 position. When the polarizer is at position 3, the reading is around 20%. When the receiver is rotated to position 0.5, the reading is increased to 30%. When it's rotated further, the reading goes down again and reaches 0 at position 2. These results demonstrate that orientation of the microwave coming to the receiver is not solely determined by the last polarizer. It is now also influenced by the first polarizer, which is electrically connected to the second polarizer. Let's recheck with polarizers at position 2. The reading is 50%. When the receiver is rotated slightly to the right, the reading increased to almost 60%. But when it's rotated further, the reading goes down again and reaches 0 at horizontal position. It confirms previous result. The orientation of microwave coming out from conjoined twin polarizers is halfway between orientation of conductors and those polarizers, which forms obtuse angle. This line is called the easy axis, because incoming microwave can easily pass through the polarizers when aligned with this axis. On the other hand, the hard axis is halfway between orientation of conductors and those polarizers, which forms acute angle. It blocks better compared to when the microwave is aligned with one of polarizer's conductors.